record this. Okay. It's the number of ways that you get what you want divided by, oops, I have a really hard time writing on this, and my pen quit working, so I'm using my mouse. Divided by the total number of ways. All right, so what is the number of ways that you can get a purple? Well, there's one purple out of two marbles. All right, so again, this is the definition of probability up here. It's kind of messy, but it's the number of ways you get what you want. We get one purple. There's only one way to get a purple over the number of total marbles, which is 2. So you're going to put it back. So you still have 2 marbles, so the chances you get a purple is 1/2. Now you start all over again. Okay, another experiment. Or there's one way to get an orange because there's only one orange marble divided by 2 marbles in the pot. You put it back in, again, new experiment. There's 1 orange out of 2 total. When you multiply that, you get 1/4. Remember to multiply fractions. You multiply the tops, you multiply the bottoms, plus, this is 1/4 over here. 1/4 is 2/4. And when you reduce that, it's 1/2. So the answer is 1/2. Okay, so does that help? Got it? Okay, good. Let's let people catch up because I didn't record right in the beginning. Okay, the problem is we have 1 purple and 1 orange in a hat. You can't see what you pick, but every time you do probability, you always assume you get what you want. So we want the probability of choosing the same color with putting it back in after you pick one. So we're going to pick 2 times. I didn't say that, but we're picking 2 marbles. First time you get a purple and a purple to get the same color, or you could get an orange and an orange. So you have to figure that out. Then remember, probability is the number of ways you get what you want over the total number of ways. So there's 1 purple out of 2 marbles. So the probability you get a purple is 1/2. You put it back in, it's the same probability. Now, how about if it was without replacement? Let's just think about this. Probability okay, so if you pick a marble, you're going to keep it. So you have purple, purple, or orange, orange. So chances you get a purple on your first pick. Well, you get what you want. So there's 1 purple out of 2 marbles. Now, so it's 1/2. But you're keeping it. So what are the chances that you get a purple on the second pick? You can chat with me if you want. Fill in the answer. You pick 1 marble. You only have 2 marbles. You have a purple and an orange in a hat, and you can't see it, or a box or whatever, and you're picking 1 marble. Pick a marble. You get purple. You're going to keep it. What are the chances you get another marble? Another purple marble is 0. There's no purple marbles left because you kept it. Great, no chance. Right, 0, no chance. So this is going to be same thing. Chances you get an orange are 1 out of 2. There's 1 orange out of 2 marbles. But if you're keeping that orange, then there's nothing left in the hat. There's no oranges left. So this is going to be 0 plus 0 or 0. There's no chance. So you can't get the same color because there's two marbles. One's purple and one's orange. What if there were, let's just make up a different problem kind of quickly because there might be a lot of questions. But how about if you had 6, let me just say red, and 8 blue? Choose, and let's just do choose marble. Doesn't matter what they are really. And let's do it with replacement and without replacement. So with replacement means you're going to pick one, put it back. So let's just do something different. Let's say, what's the probability we get different colors? So what could we get? We could get a red and a blue, or we could get a blue and a red. Chime in if you don't understand. But you have to write out all your possibilities first to even begin the problem. So again, I'm picking 2 marbles, 6 red, 8 blue. Different colors means a red, then a blue, or I could get a blue, then a red. So this is fill in the blank. How many red are there? Again, probability is you get what you want. So how many red are there? Well, there's 6 ways to get a red. There's 6 ways to get what you want. Good. So then it's, right, Charmaine, 6 out of, what's your total amount? What are your total number of ways, or total number of marbles? 14? Yep, 14. Okay, so this is the red. And, because we're picking 2, a blue. Well, there's still, and we're putting it back in anyway, so there's 8 ways to get a blue, and there's still 14 marbles because you're putting it back. It's with replacement. This is the number of ways to get a blue. Or means add. We could get a blue so 8 out of 14. There's 8 ways to get a blue out of 14 marbles because 14 total. Again, probability is the number of ways to get what you want. And then red is 6 out of 14. Because you're putting it back in, you still have 14. So this is blue and a red. But let's do it. I'm just going to set these up. Let's do it without replacement. Again, stop me anytime if I'm going too fast. Okay, so that means you pick a red and you keep it. So you still have 6 out of 14 ways to get a red. But now, how many ways do you have to get a blue? What would this next answer be? How many blues? If you got a red, okay, again, you always assume you get what you want. You got a red, how many blues are left? Okay, well, that's total 13. 13 totals would be left. So, right, this would be one less the denominator. What would the numerator be? Because you've picked one and kept one, there's only 13 left, but I want a blue one, so the blue, you assume you're going to get a blue, you still have 8 ways. You still have 8 ways to get that blue because you did not get a blue on the first pick, you got a red. You always assume you get what you want. Okay, does that make sense? Great. Okay, So, and then or, so you add, you could get 8 ways, again, new, start over. You have 8 ways to get a blue marble, but you're keeping it, but you didn't get a red, so there's still 6 red left over, but you kept one out, so there's only 13 left to choose from. So that's kind of the difference if you got different colors. Okay, great. All right, let me just do one, since we're on this, let me just do one more of the same color. Let's do, again, we have 6. Will you be starting all over again with all? I'm not sure I understand what you mean. On a new example? Yes, I'm going to start all over with same colors, but it's just here. I'll let me say we have 6 red again and 8 blue. Okay, this time we're going to do same color. Probability we get 2 of the same color. We're going to pick 2 with replacement. That means we're going to put it back. So same color, we could get red and a red. So remember, and means multiply, or we could get a blue and a blue. Okay, I'm going to go a little faster on this one. We're keeping it. So there's 6 red out of 14. You're going to put it back. I'm sorry, we're not keeping it. We're putting it back. With replacement means put back. So if you put it back, you still have 6 red to choose from out of 14. And the same with the blue. If you start with 8, and again, you're only picking one marble, but you have to remember the definition of probability. Definition of probability is how many ways to get what you want. There's 8 ways to get a blue out of the total number is 14. So even though you're picking one marble, you have to think about the number of ways to pick it. And you're putting it back, so you still have 8 out of 14 ways to get a blue. But think about this by keeping it without replacement. That means you keep it. So red, red, you still have the same color. We're picking 2 marbles, 6 out of 14. But tell me what this next fraction is going to have to be. You got a red. Now you want another red, but you kept that red one. So how many red are left in the hat or the box? Almost. Do we still have 6 red ones if we kept a red? Your 13's right. Yes, 5. Your 13's right because you kept 1, 5. Because you got what you wanted and there's only 5 left. Same with the blue. Okay, we're starting all over again because this is an or. It's a totally another situation. So we want a blue. We would have 8 out of 14. What would the next fraction be if you kept the blue that you got? Again, remember, you assume that you get what you want. Yes, you got it. 7 out of 13 because you got a blue, so there's only 7 blue ones left. You always assume you got it. And then there's only 13 left to choose from because you picked 1 out of that 14. So I think you got it. Great. So I just want to concentrate on how to set these problems up, because if you know how to set them up, then you can finish them. I mean, I can go ahead and finish it, but the point is, I want you to see how it's set up. So, I mean, did that help? We can do some more examples like that if you want. No, and means multiply, or means add. I didn't get your email, Tanisha, unless you did it right now. I never got your email. When did you send it? If you can send it again, did you send it to DJ LeGrand? Because I have my phone right here, and I was looking up to see who asked questions, and I don't have it. Can you either send it again? 626, huh? Let's see if it's... Would you be able to send it to me again? Question 1 and 2. Okay, I can look at that. I have all the learning texts right here. So if you tell me that way, that would be that I can just look them up and we can cover either those problems or I can make one up. So the question is Learning Chat 2.3. Okay, and the question is matching. All right, you have 8 cards. All right, is there a specific one on 1 and 2? Because these just have to do with formulas. I covered like the conditional probability last time, and okay, what I'm going to do is make... Oh, you were able to work number 2? Okay. I hate to just do the exact same one, but you're still in question 1. All right. What I'm going to do is do question 1. All right, we have, but I'm going to change it up a little bit and then see if you can't tell me the answer. So let me type. Okay, so question 1 says we have green that are 1, 2, 3, 4, 5, and we have yellow that are 1, 2, 3. Okay, that's kind of close together, but I think you can see we have 8 cards. We have green that are numbered 1, 2, 3, 4, 5, and we have yellow that are numbered 1, 2, 3. And I want the probability. Let's see. Okay, let's see. G is green. And let's say O is odd instead of even. The problem is even in the book. But let's say this is number 1, Learning Check 2.3. Okay, so what is the probability that it's the first question, it says, what's probability it's green? Let's do the probability it's yellow. So again, probability is the number of ways to get what you want over the total number of ways. Now, we're picking one thing here. So, how many ways are there to get a yellow? Just a plain yellow card. Yes, 3. Good. How many ways are there? Well, not really ways. So how many cards are there? Out of how many choices do you have? We have 8. Sorry, we have 8. We have 1, 2, 3, 4, 5 green, and we have 3 yellow. So 5 green and 3 yellow are 8. We have 8 cards. Do you see that? Yeah, I know. I'm sorry. I didn't type it out really good, but it's the green are 1, 2, 3, 4, 5, and the yellow are 1, 2, 3. Okay, so what would you say? Let's go back to the original problem. What's the probability that it's green then? Just give me a fraction. The question is, what's the probability it's green? You're picking one ball. I'm doing another example. You're going back to the original. 5 out of 8, right? That would be 5 out of 8. Okay, the next question is probability it's green given that it's odd. Now, I know the original problem says even, but if you can do this one, you can do that one. Now, given means that we know, okay, I'm just drawing sets, that it's odd. So it has to come out of all the odd numbers. So green is going to be a subset of the odds. When you have a problem like this with that line, that means green, I can't really write on this thing, but sorry, green given odd. So we know when you have a problem like this, the second number is what you look at first. No, we don't have 8 anymore. So 8 can't be our denominator. It has to be coming out of the odd numbers. Oh, you're writing now? Okay, that's fine. So, I'll just, okay, so this is the probability that it's green and odd. That probably wasn't a good choice with that 0 because it looks like a 0, but it's an odd. Over the probability it's odd. So in these given problems, it's given that it's odd. That means it has to come out of all the odd numbers. Out of the 8 cards, how many are odd? I'll give you a minute to think about it. We have 5. Yes, 5. 5. No, we don't have 8. It's not coming out of 8 because we know it's odd already. So the mistake people are making is that they have to cut down the sample space to what's given. So this is making your space smaller. We know it's odd. In the 8 card, if you do it out of 8, all those 8 cards are not odd. So in these given problems, this makes your space smaller. It's going to make your denominator smaller. So your denominator is going to be 5. There's 5 odd cards. There's a green one. Yes, the denominator is only the odd numbers because this problem says given it's odd. So we know it's odd. So that's your denominator, is a green 1, a green 3, or a green 5, or it could be a yellow 1. That's yellow. A 1, or a 3. So there's 5 ways. A green could be 1, 3, 5, or a yellow could be 1, 3. Now, out of those that I just listed have to come the green ones because your numerator is green and odd. So how many are green and odd? 3. Yes. 1, 2, 3. 3. Your answer is 3/5. So on the given problems, you're going to use this formula. Great. This number right here, whatever's given, is your denominator. This right here, whatever's right there is your denominator. So it means out of, yes. Out of the odds. Or out of whatever that is. Yes, Robert. That is out of. Okay, so let's try this one. Same cards. So we had, let me repeat it. We had green 1, 2, 3, 4, 5, and yellow. What do we have? I mean, I could make something else up, but I want to be kind of close so you can be able to do the homework. I spelled yellow wrong. Well, we'll just continue. Okay, probability. When the text says given, is that out of? Yes, that is what you're taking it out of if it's given. So the probability, it's yellow, given, it's even. Now this isn't in the problem. I'm just making more up so that you understand it. So see, take a minute. See if you can get this one. You're just picking one card. One-third. Yay, you guys got it. 1/3. Yay. Okay, because even numbers are going to be in the denominator. So no matter what color they are, they're even. 2, 4, green, and yellow is 2. Those are all the evens. So that is, there's 3 of those. And the top is yellow and even at the same time. So there's just one of those right here, the 2. So it's 1 out of 3. It's a yellow 2. I didn't even have to do that because it's right here. So 1 out of 3. So again, the given narrows down your choices in your denominator. So what's the probability? Oops. That it's, let's see, says green and even, so let's do yellow. Well, we already did yellow and even. Okay, I can't just erase one little thing. So let's do green and odd, which I already did. Well, we'll just do this one, green and even. Okay, now this is not a given one, so we're only picking one card. What cards are green and even? Well, there's a green 2, and I always list these out, in a green 4. So there's two ways to get a green and even card at the same time. You're only picking one card. Now, this is not multiplication because we're not picking two things. There's nothing to multiply. Okay, this and means at the same time because you're only picking one card. So that's where it might get a little confusing. If this was a green first, then an even with 2 cards, then you would multiply those 2 together. So I hope I'm not confusing you, but you're only picking one card, so they have to be green and even at the same time. Good. Okay, out of how many? Well, again, you have 8 cards. We don't have any restrictions on the denominator. So it's 2/8 or 1/4. I'm not going to reduce it, but there's no restrictions. I have 8 cards that I'm picking from. So let's see. What about or? What about yellow or even? Here you're going to have to be careful. You don't want to pick anything twice. So what are the chances you get a yellow card? Well, you have a yellow 1, 2. Let's see if Robert's right. We have a yellow 1, 2, 3. Or even. Or all the even cards are green 2, 4, or a yellow 2. But you already have a yellow 2 right here. So you don't want to count it twice, so I'm not going to list it. So I'll put it down here as a yellow 2 because it's even, but then you're going to subtract it out. Otherwise, you'd count it twice. So how many possibilities for yellow or even are 1, 2, 3, 4, 5? So we have 5 over 8. You have to be really careful on the ors. Okay, our denominator is still 8 because we're just picking one card. It's not out of a certain set. It's out of all 8. Okay, the only time your denominator is going to change if you have a given, and that given means that you know where it's coming from. Okay, let me just say this too. Let me go back to this yellow or even problem. The formula is actually this. So if you see this formula, you should recognize it. They're mutually exclusive. So what you have to do is you're adding, or means add. Okay, so we have that part. Yellow or even means add. But this means that you subtract out what's both so that you're not counting anything twice. So that's what you're going to do when it says green or even. So the other way that you could do this is say, how many yellows are there? Well, there's 3 yellows out of 8. This is the same question we were working. I just want to show you you're going to get the same answer. Plus, how many evens? Well, there's 2 green evens and 1 yellow even, so there's 3 of those. And then you're going to subtract out the yellow even, and there's 1 yellow even. And so we have 6. 3 and 3 is 6, minus 1 is 5. We get 5 A's. Same answer we got by throwing out that yellow 2. Okay, but this is how you would work the formula. So the question on the piece of paper, number 1, is probability you get a green or even. So that would be the probability that you got a green plus the probability you got, I'm going to let you work this one out before we move on, and then the probability minus the probability you got a green and an even. Okay, so work this one out because that's the one on the sheet and see if you can get the right answer. Again, we have green 1, 2, 3, 4, 5 on the cards, and for yellow we have 1, 2, 3. And tell me what the answer to this problem is. You're picking one card. You want the probability it's green or even. And just answer it in the chat. And you don't have to reduce, but if you want to, that's fine. And then one last one I saw on there that might be one that you want to go over is probability that it's odd given it's yellow. 5 ace. You're miscounting. It is out of 8, Charmaine. It is out of 8. Try it again. No. Oh, okay. 3 out of 8. No. Let's break it down. No problems. It takes a while to get this. The probability it's green. Let's start with that. Let's just do the first part. What are the chances that you get a green card? 5. 5 out of 8. Great. Okay, so this part is 5. There's 5 ways to get a green card. Or, what are the chances you get even? Doesn't matter the color. How many ways are there to get an even card? 3. Great. 3 out of 8. Yes. No. 6 out of 8. Yes. The original answer is 6 out of 8. Yes. Because you subtract the green and the even. So you have to subtract this one, this green 2, and this green 4. so that you have to subtract 2 of those because you're counting them twice. And you don't want to count those twice. You've counted that 2 and the 4 in the green cards, and you count that 2 and the 4 in the even cards. So you have to get rid of them because you counted it twice. So that is 6 out of 8. Now, if the sets don't overlap, then you have nothing to worry about. But these 2 sets overlap. So then you have to subtract it out so you don't count twice. Okay, does that make sense? And that would be 3/4. Yes, 3/4. Oh, the 2A's right here. This last part right here, green and even. So you look at all the greens, and it has to be even at the same time. So that's a green 2 and a green 4. Those are even numbers, and they're green. So that's where the 2 comes from. The 2 and the 4. There's 2 ways to get a green that's even at the same time. Okay, let's try this one. Last one, and then we'll try a different problem. Probability, same set. Go back to the 8 cards. Probability that you get an odd one given that it's yellow. Okay, let me add this both. Okay, this is a given problem. Remember, with the given problems, your set gets smaller. What does it have to come out of? How many does it have to come out of? This is the probability that it's odd. No, the denominator can't be 8. Okay, it's given yellow. Are there 8 yellows? We know it's yellow. That means we know we have a yellow card. That has to, yes, 3. It has to make the set smaller. So if it's given yellow, that means we know it's a yellow card, and there are 3 of those. 3 of those. So the denominator has to be 3. Again, the picture for this means when you pick a card in this given situation, you know it's yellow. How many odds are in that yellow set? 2. 2 out of 3. Yay! You got it. So the numerator is odd and yellow. Well, that's yellow 1 and 3. And the denominator is yellow. So how many yellow cards are there? Well, there's only 3. There's yellow 1, 2, 3. So it's 2/3. 2 out of 3. I think a lot of times people just overthink this, and they think too hard about it. You always have to go back to the definition. I think I know that's a lot of problems here, and I used to do it too when I was learning this. You just overthink it, and if you know the definitions, you just stick with them and don't waver. Yes, Robert. In this week, not all of them, but most of the questions in the learning checks and the knowledge checks, the numbers change. And I know, but that means if you know how to do the problem, then write down the answer anyway. So the next time you do it, you'll know how you figured it out. And practice makes perfect. That I know that's you hear that all the time, but it's true in math. You really have to practice it. I have time to do some more if you want this kind, or Tanisha, I guess I didn't answer you, number 2. Are you still with us? Number 2, I can just do really quickly. Okay, so let's look at this. We have, I'm not going to add all those, I'm not going to add all those zeros. So let's just say we have 281 people. Let me type this. This is better. Okay, over the age of 5. Sorry. Okay, over the age of 5. Let's say, so 55 do not speak English. I can talk a little bit about mutually exclusive also, yes. Do not speak English at home. Of those who speak another language, 62.3% speak Spanish. So, what's the probability that you don't speak English? That little thing right here means not English. So again, probability is the number of ways to get what you want. How many do not speak English? Okay, 55, right. 55 out of the total. The total is 281. Okay, and I read the problem wrong. Of the 55, let me add this. This 62.3%, you have to read this really carefully, is out of the 55 that don't speak English. Okay, so here, that's a really tricky problem because it says, of those who speak another language at home, well, 55 speak a language other than English at home. So out of those 55, 62.3 speak Spanish. So we have to take 62.3% of 55. It's not out of the total amount of people, it's out of the 55 people. So what is 62.3% of 55? Well, I have my calculator, so 0.623 times 55 is 12.65. All right, now we want the probability of those that do speak English. Okay, well, you either speak English or you don't in this situation. That's how you have to look at it. There's little things you assume in these problems, and in this problem, you have to assume that you either speak English or you don't speak English. So it's going to be 1, the formula is 1 minus the probability that you don't speak English, because 1 is the total. Probability has to always add up to 1. So, or you could look at it this way. Here's 281 people, 55 don't speak English. What does that leave? The rest? Well, you subtract. So 281 minus 55 is 226. So this is going to be 281 minus 55. I'm just going to set these up really quickly because we're getting to be time. I don't mind going over time, but I'm just going to go through and set these up. So you have to take the total number of people and just subtract 55. The rest of them, this is non-English. Okay, great. Not English. This is English. Okay, next part. Spanish and non-English. Okay, I wish you could just write part of this. Okay, maybe I can fit in here. Spanish and non-English. So we said and means multiply. And the way we have to look at this is the probability that you speak Spanish just give me a second. Let's see, Spanish times the probability it's not English. Okay, so I think I multiplied something wrong. Let me check this. I think I multiplied that wrong. 62.3. This is point. Okay, so of those that speak Spanish, the probability you speak Spanish is 34.26 over 281. Wait, I'm sorry. Let's see. No, it's not. That's not 281. It's out of 55, sorry, because those people don't speak English. So this is kind of a given problem. And this not English is 55. Oh, let me erase this. It's getting messy. Okay, sorry. Probability, Spanish, and not English. Okay, what makes this tricky is that these two are in the same set. So it's hard to, I'm kind of in a rush, that's why I'm messing up. Of 55, 62.3% Spanish. Okay, that figure, when I did it on the calculator, turned out to be 34.26. So if you speak Spanish, you're certainly not speaking English. So this set is this set right here. So your answer is just going to be that out of the 281 total. Because this is the same. If you speak Spanish, you're not speaking English. That's what makes this problem tricky. It's not a multiplication problem. You can make it a multiplication problem, but we're not going to do that. Okay, when you multiply this out, I'm going to just give the answer here so I can move on to the last problem. If you do that, it's 1.1219. So you have to remember, when we move on to this problem, the given, it's going to be out of those that don't speak English. So the formula is P, S, and not E, over those that do not speak English. So this is going to be the answer above, which what we got was 1.219 out of those that don't speak English was 55. I didn't do this on my calculator, but you can do this on a calculator. 55 divided by 281. We did that as part A. Okay. Let me just say, I should have gone into this in more detail. I should have done this. Well, actually, no. This will work. This will work right here. This is on the calculator 0.623. Okay, so that's going over Learning Check 2.3. Now, I mean, I can stay on if you want. Robert asked a question about mutually exclusive, and that means you cannot have something be the same thing at the same time. So I'm trying to find an example. So while I'm finding an example, go ahead and ask me anything that you have questions about. Unless, Robert, if you have an example, I could go over really quickly. I can't find one, but what I can do, oh, you're driving. Okay, what I can do is I'll come up with an example and try to explain it and just send it out to everybody. Basically, I mean, I'll just go through it really quickly before I can find an example. Right now, I don't know why I can't think of one at the top of my head, but mutually exclusive. If two events are mutually exclusive, then the probability of A and B happening at the same time is impossible. So it just basically means you can't have a red and a blue marble at the same time. If you're picking like marbles and you're only picking one, you can't get a red and a blue because you're only one marble. So that possibility is 0. Combinations, permutations. Yeah, sure. I did that in the first collaborate session. So if you want to look at that, that was all about combinations, permutations. Just quickly. Okay, just quickly. Permutations is order. Oh, you asked me about the Wendy's. I do want to answer this. There's no order in how you put things on hamburgers because a pickle and a mustard is the same as a mustard and a pickle. So combinations have no order. So the way you think about this is, again, let's do mustard, pickle, or pickle, putting on a pickle, then a mustard. What you do is you make up an example like this and ask yourself, does that really matter? This does not matter. So we say that these two things are the same. Whether you do mustard, pickle, pickle, mustard, same thing. So this would be a combination, no order. An order would be just the first thing that pops in my mind is like a baseball team. You have a first base player, a second base player, a third base player. You have specific positions. And Bob being on first base and Sue being on second is different than Sue being on first and Bob being on second. So if that's different, then this is a permutation and there's order. So that's kind of how you tell. But again, if I didn't answer your question in the first Collaborate session, because we did do lots of examples of that, then please let me know. And if you ever have other questions, I can go ahead and do a collaborate session and just let people know I'm on, or I can just make a short video if you need another video. I know you're probably tired of watching videos, but that's the only way you can learn online, I guess. But I will always be happy to make a video of something you don't understand. So I hope that helps. And send me your questions and I'll continue to answer them as much as I can. And I think this was a really good session. So thank you for joining. Yeah, Charmaine, thanks for joining. Thanks, Robert. Thanks, Tanisha. And thanks, everybody that came on. I hope, like I said, if I didn't answer everybody's questions, please be patient, and I will, I can make a little video and email it to you. All right, well, everybody have a good evening.